I'm recording now, Steiner. I'm recording
Are we
now.
doing a review tomorrow?
Yeah. All right. Number one, cotangent x,
1 over sine.
secant x.
Can we just run it on Tuesday?
No, I have a history class on Tuesday.
I think it's cosecant x.
So we're gonna do this. I'm gonna rechange cotangent into cosine over sine. If you start forgetting to write the x's, it's not a big deal. And I'm gonna rewrite secant as 1 over cosine.
So the answer is 1 over sine.
Which means I'm allowed to cross this out.
So 1 over sine.
So 1 over sine, but I want this as simple as possible. So I don't want any denominator. Cosecant. Cosecant. Okay. I changed this to sines and cosines. Then cross this out.
Final answer doesn't have an x. Would you mind just pull it out?
Probably not. But you should have an x. Or whatever symbol I give you. Sine x times cosine x minus sine x. All right.
We just have to memorize the sheet, basically. We just memorize the sheet.
You got to know the formulas, yeah.
Yeah, but that's really all we need to know, right?
Yeah, and apply them, yeah.
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 You know what one of those is.
Mm-hmm.
Do you have another sheet?
So I have another, the formula sheet? Not right now, no. So I'm going to distribute this.
Can you give me it tomorrow?
Sine x cosecant x minus sine squared x. Cosecant x, I could rewrite.
Wait, sine? Why isn't it sine x squared?
Because the sine is.
The sine itself is squared, not the x.
Yeah,
So we.
Because the x is a random number.
Yeah, but there's an x in both of them, so it should be sine squared x squared.
No. It's just sine squared x.
Then you cross out the signs, right?
It's just sine squared x. So this is going to be 1 over sine.
Cross out the signs.
We could cross those out. Minus sine squared x.
So 1 minus sine squared x.
So cross these out.
And is that cos?
So 1 minus sine squared x,
Cos squared x.
which you should know, 1 equals sine x or squared x plus cosine squared x. This is a Pythagorean identity. You need to know that. Which means,
So that means if you minus.
if I subtract, go ahead.
Well, minus sine x.
Yeah, sine squared x, that would be cosine squared x. Wait a second. That's literally what I have here. So I'm going to rewrite this as cosine or cosine squared x. So that's as simple as possible. All right. I'll keep number 2 on the
Is
board.
this test hard?
If you don't know the trig identities, yes.
Can you say what you wrote in the little term?
Cosine squared x.
How is boba made?
I can't go back to class.
Squishy balls.
I went halfway there.
Oh, yeah.
Turned around.
So 1 minus. Oh, that's cosine
By the way,
squared.
son, Mr. T said you're a legend.
Mr. T, that's cosine squared x on top. That's
What is it?
cosine squared x on top.
No.
Oh, yes.
No.
Okay.
That was the weirdest thing I've ever seen you do in my life.
So
That movement.
the top one, we kind of already know it should be cosine squared x.
Why disrespecting?
No, I've seen.
Now this one, this is another trig identity.
Cosine. Oh.
It's going to be, oh shoot, is it 1 equals cotangent minus cosecant?
Does someone have the
Stop
paper?
talking like that.
Mr. Tubble, switch it up with me.
Yeah, sure. Let me just make sure I don't mess up on the video. Not again, at least.
Why is this like the one time no one's wrong?
Pythagorean trig identity.
According to QMAP, Pythagorean trig identity, sin 2 theta plus cos 2 theta equals 1 rightwards double
I just
arrow.
don't want to make a mistake on the video. That's why.
Send him. Oh shoot, is the recording going on or can I?
Yes, the recording's going on, so please hold yourself back for
Palmer is
once.
back. Actually,
Pom wasn't here.
who's Palmer?
You said Pomerlin's back.
What?
Did you not just say that?
Say Palmer is back.
Oh, Pomerlin's back.
Palmer had himself a few days.
Cosecant squared x minus cotangent squared x. All right. So I could rewrite this one if I rewrite it a little bit. Cotangent squared x equals cosecant squared x minus 1.
hope this doesn't affect my capability of getting a job at Hawaii.
And then this one is going to be
Hopefully Tamir Schwab doesn't find out.
Send it, trust your heart.
cotangent squared
Your heart's in
x.
the right place, so do it. No, Curtis,
You
it's
guys are
not
just
right.
boring
Don't
people.
rush it.
Like, you guys don't have lives of your own, so you guys just like to attack other people. Like, you just get lives.
Okay, we're
My
stopping.
life revolves around
Steiner. It's over now. So then it's cosine
One over ten?
squared x over. You could do 1 over tan, but then you still want to change all the signs of cosines. Sine squared x. I'm going to rewrite this.
Cancels out.
Well, let me rewrite it. Yeah. Cosine squared x over 1 times. Remember, you multiply by the reciprocal. So it's going to be.
Wait, what do you mean over 1? It's just 1. Why do you mean over 1?
Because I'm writing it as 2 fractions, so it's better just to write it over 1. So it's not, at least to minimize the confusion. And then, cosine squared, crisscross. So it's just sine squared.
Ooh, that was fun. Wow.
Why did sine squared x go on top?
You remember, when you divide a fraction, you multiply by the reciprocal.
Oh yeah.
Number 4.
This is just annoying. Like it doesn't.
Go ahead, say it.
Like it's not like I don't think it's hard. I think it's just a lot of work and it's easy to do stupid mistakes.
So it's hard.
No,
Then what do you mean?
you just need to focus. It's not like
It's definitely
hard.
something you need to focus on.
It's
Or
not like
practice.
hard, you know what I mean?
Mm-hmm. All right. So for this one, I'm going to multiply. I need the common
Can you
denominators.
just X out?
No, because this is a plus sign. If it was a times, you could. But
So multiply left side by
You see,
cosine,
that's
the other
what
side
they
by
can
Mhm.
trick you over.
good. So this one is cosine times cosine, and this one needs a 1 plus sine. 1 plus sine.
Is it just going to be like cos squared x? Is that what that one's going to be?
Cos squared x for sure, yeah. So this is going to be cos squared x.
Can we combine like the denominators? Like, can we just make it one big thing?
Yeah, you go into eventually.
Mr. Tobel, do you like boba?
I don't think I ever had, so.
Don't.
1 plus.
Do you like boba?
No. How does it taste like compared to mocha tea? I have matcha tea.
I never tried matcha. I'm too scared.
Yeah.
Wait, do you like ice matcha or hot matcha?
Ice.
Never tried matcha. I'm too scared. What does it taste like?
It's like grass.
That's actually not a bad description. I just don't know how to describe it though.
So why don't you just eat grass? It's free.
You can't eat grass though. I'm not kidding.
Is that against the law?
Put it in a-
It hurts you, I think, more. It's more a health issue.
Why is that?
Oh, that was actually not a bad question.
Yeah. Ali's just a hater.
I admire that question.
I guess if it's your own lawn, it cannot be against the law.
I've eaten grass. We've all eaten grass.
As a kid, for sure, yeah.
I remember that.
Wait,
Okay.
wait,
I do
Mr.
like
Tobel,
that.
how did you get the 2 sine?
Oh, you gotta remember, it's FOIL technically.
Oh, you have to boil it.
So don't write just 1 plus sine squared, okay?
Wait, I'm so confused on how you got everything to be on one line.
Because I made the denominators common, I could just put it as 1 line. The whole purpose was to put it on 1 line.
But then why, if you're foiling it, then why isn't it cosine squared x squared on the other one? You just said it's foiling.
I'm not foiling the bottom because I'm hoping to cancel it out.
The cosine x on top.
Cosine times cosine is cosine squared x. And then 1 plus sine
How did
times
the bottom come to be?
1 plus sine, I just put them next to each other, is 1 plus
No,
2
yeah,
sine
I
x
don't get it.
plus sine squared x.
How did the bottom come to be?
Cosine times.
Where's the square?
I didn't square anything. No. These don't combine. These don't combine. This is going to become 1 denominator. So it's a common denominator.
But how is there? Oh, I forgot.
Yeah. Like
That's-
2 over 3.
No, yeah, like make it 6. Okay.
Yeah. It doesn't become 6. You're right. It becomes 7 over 3. Okay. All right. Let's continue. Cosine squared and sine squared. If I rewrote this a little bit, on your test you don't technically have to rewrite it, but I'm just going to rewrite it. Wait a second. Cosine squared and sine squared. What does that give us?
1.
Good.
So can I cancel
So you could simplify that to 1.
this and this equals 1?
So this becomes 1. Remember, it doesn't completely disappear. It's technically 1 plus.
I can't read what's under the red line.
Cosine squared x plus sine squared x. I just put that sine squared on the back behind the cosine, just to cross it out. Now, on the test, you don't have to actually move it to cross it out. I'm just moving it to be a little bit more clear
Wait,
for
what
us.
did you cross out?
Cosine squared and sine squared, which was
No, that's wrong.
this and this. I just moved them together. That's all. All right, wait. 1 plus 1 is? 2. I'm going to go over here.
Smart people.
2 plus 2 sine x. Wait a second. If they both have...
No, it's not 2 sin x, it's just sine squared x.
No.
We do a
No, no, no.
2 sin.
Because this is 2 sine x.
Where'd you get 2 sin x from?
If you FOIL it, you get sine x plus sine x, which is 2 sine x.
Can we do factoring?
You could factor it out. It's the same thing on the bottom, so I'm not going to rewrite it. Then we're going to factor the bottom. So 2, 1 plus sine x. Wait a second.
Factor that out on the bottom.
I did not factor it out on the bottom. I'm just like, I didn't want to rewrite it again, but cosine x, 1 plus sine x. Wait a second. What's the same on top of the bottom?
So 1 plus sine x.
Good.
Wait,
So
what happened to, why did sine squared x?
the sine squared x was moved over
So
here in the
2
red
over
and then crossed out to
cosine
1.
x cos x.
Why?
So I can make it into 1, which allows me to keep going.
So what is it? 2 over cos
I already
x?
factor at the bottom.
I don't want you to factor. I don't want you to FOIL the bottom.
Oh, I already thought that.
If you do, you got to factor it back out then.
Oh.
Because so I could cancel out the 1 plus 9.
This is so over my head.
It's your review.
Yes. So 2
Over cosine x.
2 over cos x, which I'm going to rewrite as 2 secant x.
Oh, I thought it would be just 2 over cosine x.
No, I don't think I would take points off, but it should be 2 secant x. I think I would be nice on that one.
Chapters is on the test.
Technically, I have to look. Give me a,
So if it's only
chapter 5.
if it's only trig identity.
You'll see in the end we'll do solutions, which is a combination of what we did last test and this test. So you'll see how that looks.
Stop looking at me, you're looking at
Alright.
you.
It's mostly like this.
And then talking
Whatever.
bad about
Alright.
you to me because you're not looking at me.
Number 5.
There's no
Here you go.
way
I finished the project.
Thank you.
Finished.
Thank you.
Bye bye.
All right, so this one, sine x 1 plus cosine x. So number 5, it's prove a trig identity. So remember, when you're proving a trig identity, you're just trying to get it to match the other side. I always recommend going from the big one to the small one. This is technically proof. Or verify, it says.
Yeah, Josh, that's what I said on the bus and you didn't believe me.
Yeah, I mean,
Oh, I thought
I don't
that was
believe
the
that
other
was
proof.
Nope, I said.
Like the ASA.
I just don't believe that.
These are all technically proofs.
I
We're
told you
using-
We're doing trig proofs. They're like, oh my god.
Yeah, I just didn't know what you were
Yeah, and
I thought you were saying like geometry proof.
Nope, I let it go. Not geometry proof, trig proof.
I
And then Adam
you
was
did
like,
not say that.
you did not believe me, Josh. You're my number 1 unsupported.
Unsupported.
Wow.
All right. Remember, I'm trying to get to here, okay? I'm trying to get to here, which means look at this one on the left side. Yeah, you could cancel it out to 1, but that's not going to get me closer to my goal. So I got to resist the urge of canceling it to 1.
It's a strong argument.
So what we're going to do is sine x 1 minus cosine x.
How did that happen?
I just put them next to each other.
But it always, these are closed.
But this one on the bottom,
What'd you put next to each other? Get a grip. Oh, okay.
Yeah.
So like what you're multiplying.
yeah. And I would FOIL these out, but you just,
Wait. Because the denominator, when you try to multiply, it becomes a perfect square.
yeah, good. It's a perfect square.
What does that mean?
So it's going to become 1 minus cosine squared x.
Wait, what? Get a grip. Wait, stop.
FOIL 1 plus cosine and 1
Oh,
minus
we always
cosine.
have to foil?
You should FOIL.
I'm
Let
sorry,
the
but-
bottom for
I
sure.
did a second one ago.
But the other one, we had to foil the top.
Yeah, sometimes you got to FOIL at the bottom, sometimes you got to FOIL at the top.
How do we know how to foil?
It's literally just, this is the worst section because I can't give you like a, this is what you do every time.
My life would be
In that
so much
sense.
easier if I didn't have to take this quiz on Monday.
Like,
So I
why
can,
didn't I foil the top, but I foiled the bottom?
Why are you looking at Oh.
you'll see why. Okay, let's do the next one. Next one, 1 minus cosine squared x. I know something about that. What is that?
It equals sine squared x.
Sine squared x. That's a Pythagorean identity.
Because
On
we
the
did it
homework, one of the
5
problems
times.
was like it was like cosine x squared.
Cosine x squared?
Yeah, and then like get factors or something. I don't
If
know.
the square is on the x, you're not allowed to do that. But if the square is on the cosine, you're allowed to do that. Unless it's cosine x parentheses squared.
Oh, you can't, like-
The square is on the cosine, not on the x, very particularly.
But if it was on the x, would it be
There's different rules that we're not going to deal with. If that's even a rule, I'm not even sure offhand. Yeah. Sine squared x. Wait a second. I have a sign at the top, I have a sign at the bottom. I can reduce this.
Yeah, but you have sine squared and sine.
So only
That's
one
fine.
sign can-
It's like sine to the 1 power and sine to the 2 power.
1 minus cosine x over sine x.
And I
Oh,
could-
so you just leave one side in the bottom.
Yeah.
Oh, perfect.
Which gets my goal. Now, the question, which is fair, is like, why didn't I distribute this first? Like, usually I'm distributing things. I'm looking at this and I'm kind of like foreseeing, like, well, sine
We
minus
need 1
cosine
minus-
sine,
Fine.
it's not really useful. Also, yeah, I need a 1 minus cosine.
Yeah.
So this one is a little different because, yeah, instinctively you want to just reduce this, but you can't.
Resist the urge, resist.
6 cosine squared x minus sine squared x
Why you about to
equals
laugh?
2 cosine squared x minus 1.
Why do you look like you're about to laugh?
Don't say that. That makes people laugh. All right.
Why are you exposing me on the video?
I think it's such a wonderful thing that I'll see people smile.
That's good. All right.
Or maybe if you don't slam people into the ground.
Can we leave
Maybe
it?
you shouldn't just jump onto the ground and blame other people.
Let's.
I have a bruise for evidence.
Oh, okay. Like everyone has bruises. Does that mean some person?
Yes, because it happened right after that incident.
When? What?
All right. We're over.
Because you were too angry. I don't know what you were seeing red.
All right. For this one.
I don't know what you were doing.
All right. Let's look at this one. Now it's hard to start, but this like I have no clue what to do with. So instead I'm going to work with the left side.
I dropped down and playing my favorite
Give this one. We're done.
Yeah.
What this? This is going to give us
No,
1.
'cause not-
Cosine squared plus sine squared x equals 1. So instead, let me think about this. I need 2 cosines, right? I need 2 cosines. So why don't I rewrite the sine squared into something else?
Oh, 1 plus.
Almost.
1 minus cosine.
So cosine squared x minus sine squared would be 1 minus cosine. So 1 minus cosine squared. X. What's up?
Why don't you do the cosine here?
This one?
No, like, why don't you do like 1?
You should get the trigger that
No, on the.
I feel like, yeah, I feel like you should give us a little.
This one?
Yeah.
This one?
Yeah.
Remember, my goal is to hit 2 cosines. So why would I want to change it away from cosine? Like, that's why you have to, this one is different. It's not as simple as, it's not simplifying, right? You have to figure out where you're going. No.
I think we'll come a lot.
So then, it's
No,
so
why?
stupid.
It's gonna help you
2
too.
cosine
I'm thinking, if I'm going down, I'm thinking, oh, like that.
If what?
cosine squared x
Yeah, but why don't we
minus 1.
Remind me of Sean.
Yeah,
selfish.
Mr. Total, please.
Yeah,
And then there we go.
it's so hard.
How many Sean?
Like we're literally just gonna have to sit and memorize.
It's just too much to remember, and then what? I'm never gonna remember this.
Realistically, all you need to know is your Pythagorean identities. That's all.
I don't like
That's the one you really have to remember. The other ones are reciprocal, which you should know, and tangent, which you should know.
Oh, word.
So it's not too much things you're learning or remembering.
But Mr. Tobel,
Mm.
if you think about it, it's so irrelevant.
Actually,
We
no.
should know how to switch
Same.
it.
If it's so irrelevant, I would lose my job, so I can't say that.
Fine, we should know how to switch it in. We shouldn't memorize
Bring
what.
back some.
Because first,
Okay. They also use great.
Wait, have you ever had all you can eat sushi?
No, I don't have generation anymore.
All you eat sushi is not that expensive, though.
It's really not. It's $33 for one person.
That's pricey. Well,
It's really not.
I mean, how much you spend on a dinner, though?
No, exactly.
I think it's.
Well, all you eat sushi, downsize the cost.
Exactly. All you can eat sushi gives you more for your money.
Not John.
All right.
You can order however much you want for one person. And it's
You're allowed to
$33.
It's $33.
Sean Bellerman eats
appetizer,
non-kosher
any, like,
sushi.
wow. Why we gotta put that on recording?
You can get anything from the
I'm
menu.
just
I just wanted that to be recorded.
We're the only ones that watch the video.
I'm sending it to Sean.
All right, this
I
one.
don't eat
It's hard to split up a multiplication into minuses and pluses, so let's work with the minus side on the left side. Well, secant x, let me rewrite it as 1 over cosine x minus cosine x over 1. So I want to get rid of this subtraction, so I want to combine them. So the best thing I could do is make common denominators. So the left side, it's okay, but the right side needs a cosine.
How are you able to do that? Oh, wait, pause. I got it.
You got it? Okay. So I'm going to rewrite this as 1 minus cosine squared x
Wait, I don't understand.
over cosine x.
Secant x equal to 1 over cosine x?
Mm-hmm.
So you're basically just plugging in different numbers and then simplifying it?
Yeah, let's see what we can do with this.
Oh, well, the top is sine squared.
Good. So the top is
Don't you have to make
sine
cosine
squared.
X, not cosine?
Over cosine.
For the red.
Yeah.
Oh, which the sine and cosine equals tan, and we still have a sine left.
Good. So I can split this up. So it'll be sine over 1 times sine cos. Wait a second. Sine over cos is
Tan.
tan. So that's sine tan. Again, sadly, like I said, this is not the typical situation where I can tell you the steps each time. Okay?
That was a good one by me, no?
Yeah, I'm good. I'm happy. Ali, you still got this done? You got it done? Get it done.
You know what?
Number 8.
Wait, how does it go from
Wait, can you, I can't make
sine
all
square
the,
x
can you
over
do
cos
the
x
circle
to
instead?
simplify?
Wait, one question at a time. Ali's is quicker. Go ahead, Ali.
Can you just read what you wrote in the circle?
Sine x, tan x, which is the matching
Sine x.
tan x, which is matches the right side.
How do you simplify it to like two brackets?
I'm really upset about that.
This part?
Like multiply by each other, like sine over
This part?
I
times
know you
no
did,
graph,
but
less
I
graph.
accept your problem.
Oh, here?
Yeah.
Oh, because you remember, they're multiplication. Sine squared is sine times sine. So then I could just split them separately, which is fine. Because it's multiplication.
Mr. Topol, how about we don't do 9 through 12 today?
But wouldn't it be?
Give
Well,
our
s-
brains a break.
Would it be cosine like over cosine too? Because it's the same denominator.
Play my favorite.
Go ahead one more time.
Like, would it be like cosine over here?
No, if it were plussing, it would be cosine over there. If I wrote cosine there, and when I combine it again, I would get cosine squared, which is inaccurate.
It's such a blur to me that Amelie and Blake.
You could technically think of it like this, if you want to think of it like that. It's one big, okay?
I'm great.
And then from there is kind of a little bit more obvious in that anyway. Okay? All right, number 8. Secant x minus cosine x over secant x
Fine, give me the scoop on the bus.
equals sine squared x.
Do I?
As I usually say, it's harder to make something small into bigger, so let's try to reduce this down. Okay?
Sure. So secant over secant, wouldn't that be 1?
Let's see. So secant x over secant x minus cosine x over secant x. As you said, secant over secant is
1
1.
minus cosine
Now, what's secant again? Secant is the reciprocal of
cosine.
1 over cosine. So if I bring this up, it'll become cosine squared x.
How would you bring that up?
I'll
Multiply?
rewrite this part. Cosine x over 1 times the 1 over secant, which means this would become, all right, let me do the arrow.
No.
Cosine x times cosine x. Okay.
I don't get how that happened.
No,
What's secant? Secant is 1 over cosine, right? So if secant's on the bottom, when you put it to the top, it's going to be
Ah, okay,
cosine.
understood.
And then it's cosine squared. Wait, 1 minus cosine squared? We know that. Sine squared x.
Okay, for
Wait.
can you please give us a break? We can't do 9 to 12, and I don't want to stop midway.
What the answer is sine x squared?
So you want to do the last part of the video tomorrow?
Yeah.
And then you'll give us more problems.
You know we're like the only class you have tomorrow, I think?
Only real class.
I honestly would.
I'll make you a
Maybe
cupcake.
I believe it. What's up?
I'm gonna make you a cupcake. Can I come and take that back if we're done?
Yeah, make me a cupcake.